Hi everyone, welcome back to the channel. In this video we are going to learn about K-Map, Karnaugh Map, a simple tool which in digital electronics to use in simplification of Boolean expressions. I will explain what is K-Map, how to use it, how to minimize a logic expression with the help of K-Map, and mainly we have 2 variable, 3 variable and 4 variable. These are very important K-Maps. So in this video just we are focusing on just 2 variable K-Map and 3 variable K-Map, and 4 variable K-Map will be covered in upcoming videos, the 5 variable K-Map also. So let's get started. Before start to learn why K-map is required, so let's see an expression in this. So this can be solved in two ways. This can be solved with the help of the Boolean algebra, the simple Boolean algebra. So I have already covered about Boolean algebra. So we can solve by taking common in the first and third term, and we can solve these things. So to minimize the circuit, or simply you can reduce the equations like that equation. So or you can able to solve with the help of K-map also. So at the end of this video we are going to see how to solve with the help of K-map as well as Boolean algebra. How K-map is easier than solving with the Boolean algebra. So we are going to compare both of them. If you draw a circuit for this expression, that is A, B, C, second one is A bar, B, C bar, third one is A, B bar, C. So all are ended. So the circuit would be looking like this. If you simplify that, then simplification after the circuit looks like that. So this is a simple circuit that we can see. So in this only 2 AND gates are required, and 2 input OR gate is required, a simple expression. So how we can minimize, let's see after things. So let's get started with the normal basics of K-map. So let's see the not definition, let's see the thing that we are going to know at first. K-map means a box. In the box we have some squares. So in that squares we have to fill all ones, like min terms we can say. So in that, with the help of min terms we can make groups and we can minimize the expression. So let's see the thing that is there. K-map can be drawn for n variables, and the number of boxes involving are 2 power n. So for the n variables we are going to have 2 power n boxes. So what is meant by that? So let's see an example. So we have started with n is equals to 0. So for n is equals to 0 nothing makes sense, because 2 power 0 1 for only one thing. So there is no variables. So with the one thing, that any constant or anything, that we can simply denote why we need K-map. So for let's see the another example. So for n is equals to 1 also we have only 2 things, that is 2 boxes only. Then also why we with the one variable, suppose assume capital A is our variable. So we can represent A bar into A bar into A bar into A bar into A. We can simply identify that. So A bar into A, that is 0, we know that. So for n is equals to 2, we have 2 power 2, 4 boxes. So this is important. So n is equals to 3, 2 cube, 8 boxes. So this is also important. So for n is equals to 4, boxes are 16, 2 power 4. So these 3 are very important, that is 4, 8, 16 and so these 3 are important. And red highlighted one, the last one, that is n is equals to 5, 2 power 5, 32. So this is also not an important one, but it is a thing that we want to know definitely while learning the digital electronics in K-map. So this also will be discussed. So the n is equals to 4 and n is equals to 5 will be discussed and covered in the upcoming videos. So in this video we are going to just cover n is equals to 2, n is equals to 3, that's it. So let's start with the 2 variable K-map. So I think you already know about the truth table of the 2 variables of K-map, that is if you take A and B as your variables. So you are going to go from 0 to 3, that is 0 0 0 1 1 0 and 1 1. I hope you know this. So you are going to write or represent these things in the what we say SOP form, sum of products, that is A bar into B bar. So if 0 is there in the place of A, 0 means A bar, 0 under B, that is B bar. So suppose the second term, if you see, that is 0 1. If you see that A under 0 is there, so you are going to represent 0 as A bar. So B under 1 is there, so you are going to represent B as B only, not B bar. So these are that's the thing that you have to represent all the things that in the K-map. So not K-map, in the truth table. So after that you are going to represent the min terms from 0 to 3, that is M0, M1, M2, M3. So I think you know this. So now K-map means it looks similar to like that. So I have represented in a black box like that 4 boxes. So I already said that 2 power 2, that is 4. So we are going to have 4 variables or 4 boxes, and say 4 variable boxes, that is first box is 0 0, second box is 0 1, third box is 1 0, fourth box is 1 1. So these are the 4 boxes variables. So this is the representation. So if you see clearly in the left hand side, that up or down, so I have wrote A and B. So the top from left to right is all B. So from top to down, that is all columns are the rows are A rows. So B columns, A rows. So that is the thing that I am saying. So if 0 is there, we can represent as B bar. If 1 is there, we can represent as B in the column wise. So in the row wise, that is if 0 is there, A bar, because that belongs to A. So if 1 is there, that is A. So simply we can normal matrix type, you can multiply A bar into A bar in the first column, A bar into B in the second one. So like that you can fill this column. Seeing the same terms from the side by table, so you can fill or replace with the min terms, that is M0, M1, M2, M3. In the place of each min term, I am going to replace M0 with the 0, M1 with the 1, 2 with the 2, 3 with the M3 with the 3, because it is a simple representation to write out there, so that you can able to understand, oh, this is that box, so that I am representing like that. So with that representation, we will see what will be our use, or how we can use that representation to represent our final outputs. So let's see with an examples also. So we will see all examples at a time, but before we are going to see, so we have two variable, so we also should see the 3 variable, how it will be looking like. So this is the 3 variable will be looking like. So I forgot to mention the the red color highlighted one is the gray code. So in the 2 variable also, that is gray code only. So as a 2 variable at the top right corner, just I did not mention that, because it's the same thing that we are going to follow for 4 variable K-map also. So the gray code is very important. So if you don't know about gray code, I am giving the gray code video in the description box, check it out. So gray code means 1 bit change. So if you go from any bit to any bit, so if you take first bit to second bit, that is 0 0 to 0 1, only 1 bit is changing. So if you take first to last one, that is 0 0 and 1 0, so the first 0 is changing to 1, that's it, remaining are nothing changed. So this is known as gray code, 1 bit change or unit distance code. And for the 3 variables, I am representing 3 variables as A, B, C. So I hope you know how to fill from 0 to 7, that is in expanded form in min terms also, that is from 0 to 7, M0 to M7, and fill that according to A bar, B bar, C bar to ABC. Yes, I have represented 2 things inside the boxes. The first thing is with the numbers, the second thing with the normal representation of as SOPs. So both the representations are same, both the representations are correct, nothing difference, because in the first one we are representing that as 0 inside term. So if you see in that normal decimal, that is 0. So here also, that is A bar, B bar, C bar is 0. So nothing changed. We can compare the first term, that is same. So we can replace with the M0 also, it's not a problem. So 3 representations are correct, because you are going to multiply rows and columns, that is A, B, C, each and every variable has to be present inside the box. So I think you know normal matrix, or how you can take individual terms if you have this side term and that side term. So this is the representation of the min terms inside the boxes for going from 0 to 7, M0 to M7. So see clearly, it is not a correct order, it is a shuffled order, because we have used gray code here. So because of usage of gray code, the digits are somewhat changed. So if it has a trick. So if you see the numbers, so first replace the M0s with the normal numbers, that M0, M1, the 1, only take the numbers, so you can able to understand how we can remember or recall very fast. So after replacing the numbers, so first observe the first row, that is starting with a 0 inside box in a purple highlighted one, that is 0, 1, just skip 1, that is 3. Skip 1 means you have to take 2 before 3. So the same pattern is followed the below row also, check that. So because so we in the first row we have completed up to 3, so start from 4, so 4, 5, skip 1, 6 and come back 7. So this is the pattern in every 3 variable K maps. So just remember these things, or you can simply follow the method, because so write in every box, that is in the first box, that is A bar, B bar, C bar, because 3 are zeros. So in the last but 7th box we have 1 1 1, so that is M7. So you can fill all that and you can check also. So you can check, after checking also you have to follow this method. You can write normal numbers and you have to follow these methods only. So as I already said, we are going to just discuss about 2 variable and 3 variable, but just for understanding purpose I am going to say about the 4 variable K map also. So let's observe what is a 4 variable K map also. So if you see clearly, so I am going from 0 to 15. So that is from 0 to 15 means that in binary also in normal decimal. So I expanded form, that is in SOP, red highlighted one, that is known as SOP form. So in the SOP form, sum of products, SOP means. In the SOP form also I have wrote. So in the terms of min terms also I have wrote, that is from 0 going from 0 to M0 to M15. So this is the truth table for the 4 variables, 4 variable truth table. So that is ABCD. So for the 4 variable ABCD, we are going to construct a K-map. So K-map will be looking like that. So 2 power 4, that is 16. So we are going to have 4 by 4 cross 4 matrix type, and you are going to represent AB down and CD down. So that's not the restricted one. You can interchange also, AB as up, CD as down. So according to your problem solution, you can do that. So let's see this one first. So first box, you are going to take AB into CD, that is 0 0 and 0 0. That is first one, that is 0. The second box, we are going to start with AB, that is 0 0, and CD, that is 0 1. So the second box is 0 0 0 1. So remaining all boxes can be filled like that. So if you observe last box, last one, so AB is 1 0, CD is 1 0. So multiply both of them, you will be going to get 1 0 1 0. So that is not the 15th term. 15th term you will be getting somewhere in the middle, because we are using gray codes, not the normal binary codes. So observe this first. So in this also will be changed, numbers will be changed. So I will be going to explain numbers also, you can remember or recall that. So as I said, I will also represent with the help of numbers also. So this is the representation of 4 variable K-map in the numbers. So if you know the conversion of binary to decimal, so this is very simple. So you can convert any digital or any binary to decimal, decimal to binary. So this is the representation of in decimal also. So you can represent in each box, so that you can understand very clearly which number is coming where. So these numbers are why. So I am going to explain why these numbers are important. So if you observe the first box, that is 0. If you observe the last box, that is 10. So any shortcut for this box also for variable? Yeah, there is a shortcut for remember this also. So if you see as a 3 variables, like, so take first row after, so 0 1, skip 1, 2, come back 3. So first row is completed successfully. Come to second row, that 3 up to 3 completed. Start from 4. So 4 5, skip 6 and write in the other box 6 and come back 7. So now it here is very important thing, you have to skip a row itself. So come to directly 4th row. In the 4th row you are going to start from 8, because you complete up to 7. So 8 9, skip 1 10, come back 11. So you have completed to 11. So start from 12 in the third row. So 12 13, skip 1 14, come back 15. So this is the simple trick I can say. So you remember this trick, or follow the method, or that is A B C D, multiply both of them and write according to binary to decimal, convert them. That's the simple method I can say, or the trick also you can follow. Yeah, this is the overview that we are going to discuss in this video. The first one is 2 variable K-map, contains 4 boxes. 3 variable K-map contains 8 boxes. So let's start with the 2 variable K-map. Yeah, we have already discussed the basic of 2 variable K-map. So just directly jump into the examples. So take the truth table of a problem that we have given with. So the output is F1. So the F1 outputs are 1 1 0 1 for the 2 variables, that is A and B. So in the SOP form, that we can represent 3 ones are there. So the 3 ones can be represented. The first one represents that A bar B bar. The second one represents A bar B. The third one represents AB. So we have already learned about this SOP formats in the previous video. So SOPs can be represented as M0, M1, M3. So because that is in decimal, that is the 0th term, first term and the third term. The simple sigma notation also 0, 1, 3. So I hope you know these representations. So we have already learned why we are representing inside box with the 0, 1, 2, 3. Because this is the reason. So there we are having min terms as in the place of 0th term, first term and third term we are having ones. Once as output, that is F1 output. So place that once in the K-map. That's it. That is the first step to do. Yeah, I simply represented the question and the K-map. So I have made it 2 groups. That is first row 1 1, the column, the second column 1 1. So why I have made like this a group, 2 groups. So I will explain what is group, how we have to make a group, why we are making groups. So these are all things I will explain now. So these are the 4 points that we can. So I will discuss very important things. This is how to the rules of making K-map. in the upcoming video. Just have an overview how we have to make a groups. So make the largest group of ones and all ones should be covered. So remember this thing, once all ones should be covered, that's the important point, and largest group of ones. And second point is make only group of 2 powers. That means you can make a group of 1, you can make a group of 2, you can make a group of 4, you can make a group of 8, like that. You cannot make a group of 3. That's not allowed in this K maps. So overlapping of groups is allowed, groups only adjacent squares. So let's see an examples all this. So in the output format also, so this is SOP, means in between we are going to get plus operator. So here we are having 2 groups. So in the 2 groups we are for the first group we are going to get one expression. For the second group we are going to get one expression. So both of them we are going to add. So that is SOP, sum of products. And one more important thing, the changing concept is there in this. Every variable in the group has to be represented if not changing. So this change, what is this changing? So I will explain this changing in a 3 variable very clearly. So let's understand in 2 variable also. While explaining example, I will explain that what is changing. As I said, so adjacent only can be made as group. So the first one is allowed. So we already saw it can be made as group. So because one is adjacent, so we made it group of 2. So if you observe the second one, so it is 4. So I said we can make a groups of 4, so it's allowed. So if you see the third one, yeah, that's also, it's not adjacent there, they are not diagonal, so we should not take diagonal also. So the corner things are allowed. So we can see very clearly in the this video only, but wait a minute, we can explore that. This third case is not possible, that is 3 ones are cross linked and 3 are not, can be grouped like that. So this is not allowed. Yes, now come back to the original question of first question in the 2 variable K map. So let's solve. In this we have 2 groups. The first one is vertically, second one is horizontally. So if we consider the group 1, that is A bar. So you might be confused how it is A bar. So the first row is A bar only, that is 0, that is it is dedicated for particularly A only. So the first one is 0, that is meant by A bar, so we are going to take as A bar. If you consider the B, the top one, that is changing from 0 to 1, so we are not going to consider that. So if we consider the group 2, that is a simple B. So how I am saying that is B? Because it is a vertical column, but in vertical column also the A is changing from 0 to 1, but B is the B only. So the output of G2 is, that is group 2 is B. So the final output that we should add both of them, group 1 group 2, then we are going to get final output F1 as A bar plus B. That is our first example's output. So I have already said that corner group is possible, corner grouping. So let's see the corner grouping in the second example, that is allowed, I said. So if you see that A column and B column, so that is the representation F1 is equals to sigma 0 3. So we have to place ones in the places of 0 and 3. That is the use that I already mentioned. So after placing 2 ones, you have to highlight that as a group, that is 2 ones are adjacent, that we should consider. So the top one, that is A bar B bar, should be written as it is. And the third, in the third position, that should also be written as it is, that is AB. The sum of those two gives our output. So if we then see the next one, that is third one, there only, if anything fully filled, like 4, if 8 columns are there for the 3 variables, so the full filled, then F1 is equals to 1. The final output would be 1. Not only that corner grouping, this corner grouping is also possible. Any corner grouping is also possible. So we will explore more corner groupings in 3 variables so that you can understand very much clear. But just remember, corner group is possible, that is not diagonal. So if you understand 3 variables, then you can understand that is not a diagonal. So if you observe here, that is the first row, so that is A bar B. The second row we have, that is A and B bar. So these are output of that. So this is also possible in 2 variable. So up to now what we have saw, these are the cases in 2 variables. So now let's start the 3 variables. In 3 variables we have many more examples to be solved. So let's start with the first example, that is F1 is equals to sigma 0 1 5. So in the place of 0 1 and 5 we have to place 1s and remaining all places 0. So remaining all places will be 0. For the simplicity purpose I am not representing the zeros, I am only showing the ones itself. So the upper table is very important, that is only filled form, that is in the 0 place, in the first place, in the 5th place I have replaced with the ones. So forgot about the first table. So we are going to see the second K map, because so the first 2 examples I will be going to explain, because that is a combined thing of both of them, that is belongs to the first row, first column and second column. So if you observe changing, so C is changing from C bar to C, so that is changing, so we need not to consider that C. So only B bar is our output and that is in the row a bar. So the final output of G1 is a bar, so b bar. So we should not consider because it's changing. All variables should be seen first. If changing, don't consider. Doesn't change, consider. In the same row, consider. That's it. This is the second group that I have made. So I have already mentioned we should not make a group of 3. So that is the reason I am making 2 groups. The first one is horizontally, second one is vertically. I hope you understood this. So second group belongs to the column, not row. That is column B bar C, and the A bar is changing from A to A bar to A. So we should not consider the A term. So only we should write B bar C. So that is our final output of G2, that is group 2. So finally these are only the min terms in this K map. So we are going to mess up, add up the group 1 and group 2. So the F1 equation would be A bar B bar plus B bar C. That is our output of the first example. So let's see the second example, that is in the position of 0, 1, 5, 7 we have to fill all with ones. So let's see that. So this is the 3 variable K map of 0, 1, 5, 7. So if you don't understand, so let's see step by step. So this is the second example that we are going to see in a step wise. So we are going to see the first group 1, then second group 2, then we are going to add up. So finally we are going to get, after 2-3 examples, no need of 2 steps, just we can write directly at a single step all. So in this also we are going to convert that 0, 0, 0, 1, 1, 1 and 1, 0 as representation. So those are nothing but the BC terms expression individually. So I am going to replace all that BCs with the B bar, C bar, zeros and ones with the BCs, like that for simplicity. So I am going to see the first one or the first term, that is first group. So 1, 1. So if you observe clearly, that is in the row A bar. So A bar is our one first term. First term is first element. So in the second one we are going to see the upper, that is BC. So in that the C bar to C it is changing, so we should not consider. So we are getting a bar into B bar. So that is our first output, that is for G1. So this is the second group that I have made, that is A into C. How that A into C got? Because that is in the second row, that is A. So if you are seeing there, I have highlighted that also, the B is changing from B bar to B. So we should not consider that in the horizontal wise. So C is same, so we should consider C. So the output would be for group 2, that is A into C. So if you consider both of them as addition, so that is G1 plus G2, A bar B bar plus AC, that is the final output for this expression. Let's see the example 3. So we should fill ones with in the places of 0, 1, 3, 5. So let's see this. So here a new change has been made, that all the replacement of ones has been changed for ones. So if you observe in the place of 1 and 0, 3 and 5, this is the use that I have mentioned earlier also, that small representations of zeros 0 to 7 I have represented inside the box. So remember one thing, you are following gray code, so numbers are not in the same order, like from 0 to 7 directly in the same order, so it is shuffled. So I have said all the trick also, so you can follow the trick, that is 0, 1, 3, 2, 4, 5, 7, 6. So according to that you have to place the ones according to the given F1 equation. So after placing that, make a group of Z1, so that is A bar B bar. I hope you know that is in the A bar column, and B bar is same, so you have to take as A bar B bar, that is first group. So this is the second group that I have made, that is G2, that is A bar C, because that is A bar column. So that is B bar is changed to B. So C is same, so you have to consider C. So that is A bar into C. So I took second group as this one. So you can take second group from the horizontal one or vertical one, that is your wish. But 3 groups has to be present and 3 groups has to be added for this example. So I hope you understood. So add both of them. That's the F1, that you have to add 3 groups, that is A bar B bar plus A bar C plus B bar C. That is the final output of this expression. So likewise you can find any of 3 groups. So for this third group I have find this vertically, that is B bar C. So A bar is changed to A. So you should not consider the variable A. You should only take the variables as B bar C, that is above that one. So that is G3 is that one only you should add. So that is our final output. So I hope you understood the procedure. So now onwards we are going to see 2 examples in the same page, so that you can understand at a time difference between both of them, and you can solve more examples. So let's see this one, that is F1 is equals to 0, 2. So 0 and 2 we have to, that those are min terms, so we have to place in the place of 0 and 2, that is ones. So I have placed both of them. So in this 3 variable K map we have only 2 ones, so we have to, both are in corners. So these two are adjacent, means side by side. We have to assume, means in the corners they are side by side, because in the gray code that's the property. If you see from B bar C bar, in the last column that is B C bar, so as it is changing from only B bar to B, C bar is same, so that is known as adjacency, not mean by side only. So this is also known as adjacency, so you have to group of them. So that is in the both of them in the A bar column, so you have to take A bar. So if you consider B is changing from B bar to B, so don't consider B, so consider only C bar, that is A bar into C bar, that is the output of the first one. If you observe that the second one, that is 4 6, same ones but the down column, so that is A. So again the same thing, that is C bar is not changed, so C bar into A. So I hope you understood, the row is A, that's it, I changed the row, that's it. Again we are going to see two examples in this. So these two are very interesting examples. So the first example is only one digit, only one thing is there anywhere in the K map. So it might be in the 0 position, it might be in the second position, it might be in the any position. So how you have to take that? So if only single digit presents, so example I took a 5, so that is everything, every variable has to be written in the output. So take that, take as a group, that is, so the one also can be grouped, because I said 2 power 0, that is 1 only. So 2 power 2 we can group 4, so 2 cube 8, we can group 8 elements. So this is the property, so you can group one element also, so that is individual group. So according to the individual group, normal matrix type representation, so the row is A, so the column is B bar C, so you have to multiply both of them corresponding to the element. So that is our final output, that is A B bar C. So if you see this next one, if all are ones, what we have to take? So already I have explained in the two variable K map, if all are present in the K map, so that is represented with the SOP format also, sum of product, that is sigma 0 1 2 3 4 5 6 7. I have to group the 8 elements, because we can group 8 elements at a time. So that is the property I have said. So now only, so if all are present, all elements are matched, then you have to take output as 1. So let's quickly solve another two examples also, how we can group, then our understanding will be become more. So that is 0 2 4 6, sigma 0 4 2 6. So you have to place all the elements in the K map. So I have placed there, so you can observe there. So that is corner group. So these are 4 elements, so I have already said. So B bar, C bar and the last, so these are corner elements. So corner elements can be grouped, so these can be grouped. After grouping them, you can see that A bar is changed to A. So I said first, so you need to consider all variables, so checking one by one variable, so that you can fix all the output. So if you see the first A, that is changing, so remove that. So if you see B bar and C bar, if you consider the first and the last row or column, so row is changing, remove that. Column if you consider, C bar is not changing, so C bar is our final output. So that's a simple output, I think so. So if you consider the 4 elements in the next example, that is 0 1 2 3, so that is in the same, that follow all in the same line, so that is A bar. So remaining all are changing, the row is same, but the column, each and every element is changing, so that we are going to take only the row element, that is A bar. I hope you understood this. Because of all changing, we should not consider that, we should only take the A bar or the row. If only column present, you should take only column, that's it. These are another two examples that we can able to follow in this session. So that is 0 3 4 7. So according to the numbers that I have placed once, so after placing that, you can clearly observe, so those two cannot be formed as a group, because the first one is corner, okay, it's okay, but the middle one is not the corner thing. So you should not group these 4 terms at a time. So you can group 2 at a time, so you cannot 4 at a time. So this is the thing that I mentioned, this example in this. So you can see the A is changing, so the rows are changing, so remove that variable. So you are only left with 2 variables, that is B and C. So the first row has to be first term, that is B bar C bar, as it is a single separate group. So the separate next group is, that is BC. So I have to add both of the groups, so that the final output is B bar C plus BC, that is our output. So if you consider the next example, that is 0 1 4 5. So see, so 0 and 1, 4 and 5, all are adjacent. So in the this example, those are not adjacent, so we have to take individual groups. So these 4 are adjacent, like a box, like a square, so that I can able to form a group. So I can form a group. So after forming a group, you can observe that A is changing, so remove that variable. So check out those B bar C bars, so B and C. So C is changing, B bar is not changing, so B bar is a final output for this expression. So these are the final two examples that we can see in this. 3 variable k maps. So we can have many examples, many combinations, but these are the main examples, I think. So if you consider 0 1 3 4 5 7, so if you consider that, so that is 0 1 3 4 5 7, you have to place all 6 ones. So see that those are 6, not all 8 are filled, only we have filled 6. So we should not make a group of 6, whole 6. So we can make only 2 4 8 likewise, the power of 2. So I also made some mistakes in my doing sometime, that I made 6 at a time. So you should not do that mistakes in exams. So see that, so the first 4 has to be made as a single group. So that is, you can see the a is changing, remove that variable. So you can see the first group, the first 4 terms group, that is b bar is constant. So the first one is b bar. The after plus, that is c is changed. So c is same for the second group, second 4 ones. So I said overlapping is allowed, so that I can allow overlapping. So I can do overlapping also. This for the second group. So as c is not changing, so that is our final out for the first k map we have done. So if you see the second k map of 3 variable, that is 0 1 2 3 4 5 6. So as we already see, that is 0 1 4 5, that is as a group. And we have also had Karnaugh group in this, Karnaugh grouping, that is 0 4 2 6. We have to make Karnaugh grouping in this. So as a is changing, so ignore a. So you only consider the b bars and c bars. So if you see the first group of 4 terms at a time, that is adjacent type, so that is b bar. You can observe many more times, that is b bar only. B bar is not changing because. So if you see Karnaugh grouping, that is 0 4 2 6, the b is changing definitely. The c bar is not changing. So that is our output for the second group, Karnaugh grouping. Sum of those two, so that is becomes our output. Okay, up to these examples, I hope you understood all the 2 variable and 3 variable k maps. So you will also follow up the 4 variable k maps in the upcoming videos. But the question that I have mentioned at the top of the first video or the video beginning, so let's complete this question also. So this is the question that I have mentioned. So let's solve with the first k map so that you can understand. So simply in place of a, right, that is not a complement form, so that is true form, that is a only. So you can take 1. So b1 c1 for the first term. So that is 1 1 1 means 7 in the decimal form. So the second term is a bar b c bar, that is 0 1 0. I hope you know how I am writing. That is according to the SOP. So that is sum of product as format I am writing there. So if bar is there, that is 0. If normal is there, that is 1, as that I am taking. So if you consider 0 1 0, that is 2. So if you consider the third term, that is a b bar c, so that is 1 0 1, that is 5 in decimal. So fill out that 7 2 5 as ones in the k map of 3 variable. Let's do that for the simple minimization of this term. So after filling the terms, that is 5 7 and 2, we are going to have like this. So 2 terms can be grouped at a time. So as there is no another corner, we only had one corner. That one corner has to be replaced with all the variables, that is a bar, that is how many variables may be present. So we have to represent all the variables there. If groups present, represent according to the groups. If changing, don't represent. If doesn't change, that represent as a group. So that's the main motto. That is the main motto of making groups. So if not formed a group, if single one is present, separately one is present, represent all the variables that are present according to that position. So you can see the group is the second row, that is a. So I can represent a. So you can observe that b is changing from b bar to b. So c is not changing. So the first term would be a into c. So the single term that is present in the a bar column. So I have a bar. So the row is a bar. The column is b into c bar. So the product term is, that is a bar b c bar. That is our k map, the output equation. That is the c. In that we have to implement. We have to implement with the 3 product terms. But in this we are left with only 2 product terms. So this is the use of using k map. You have already seen the f1 expression. So you already see the f1 equation on the circuit diagram also. So after minimizing, so this is the simple minimized circuit diagram. So you can see how the circuitry has been reduced. So this is the same outputs would be same. Circuitry would be reduced. So this is the main advantage of reducing with k-maps. Very big expressions can also be reduced with the help of k-map. So this same expression can also be solved with the help of Boolean algebra. It's not a big problem by taking commons and all. So now I will show that also. So this is the thing that I am talking about. If you don't know how to take what is meant by that, so you can know about Boolean algebra by clicking in the description box. So I am giving the video of Boolean algebra. So let's see if you know how to solve Boolean algebra. It's nothing but it's not like normal maths only. You can see the first and third terms. So you can take AC and AC common. So after taking AC common, you have left with B and B bar, B plus B bar. So in Boolean algebra, we know that B plus B bar or A plus A or any variables. So it would be 1. So remove that you have left with A dot C into A bar B C. So that's the same output that we have reduced with K-map also. So you might think this is the taking common and just one step output. So you can use this normal Boolean algebra. Yes, this example we can use Boolean algebra, but very big expressions like if you have 7 sum terms, so we cannot take 7 in that we cannot take 2 to common, and we can not solve very easily. It's a very big complex tough task. I hope you know what is meant by SOP or POS. Up to now what we have seen, or what if you are putting ones in that. So you have saw that sigma 0 1 2 3 4 5 6, if that example is given. So that is a very tough example to solve, because this expression C, so that is A bar B bar C bar plus A bar B C bar, like this term only, F1 equation only, they will give up to 7 terms, 7 sum terms or product terms. So we have to solve that. So that is a big expression. So likewise solving, suppose they have given assume 11 terms, 11 product terms in 4 variable K-map. So that becomes our headache, so that we are using K-maps without using Boolean algebra. So we can also use Boolean algebra to solve, but it is a simple way to use a K-map. So I hope you understood in this video 2 variable, 3 variable. In the upcoming video we are going to solve 4 variable also. What is prime implicant, essential prime implicant, 5 variable K-map also. So stay tuned. Thanks for watching up to now.